Okay, so hi everyone. Uh, this is my first YouTube video, so I might be a little lost, but please bear with me. So I'll just start off by explaining what this channel is about. This channel is just going to be me discussing a few coding questions and explaining solutions that I find are interesting. And yeah, that's all. So I know there are already a lot of channels out there that do this, but the reason I'm starting a new one is firstly because, well, this is something that I would really like to do. Uh, Secondly, because I'm currently trying to learn data structures and algorithms and get very good at it. Uh, so explaining questions like this uh, would help me understand if I myself really understand the concepts or not, right? And thirdly, because I would just like to share the perspectives and the approaches that I have to the questions, and hopefully it can help you guys. Um, that's all. So I guess we can just get right into the question, right? So yeah, so this is the question that I'm dealing with today, and it's called linked list cycle. You can find it on Leetcode. Uh, I'll share the link in the description too, so that you can go and try out your solutions before looking at my solutions. Uh, but yeah, so the question is basically this, that we're given the head of a linked list, and we have to determine if there's a cycle in the linked list or not, right? And what a cycle basically means is that if any node of the linked list, if the next pointer of any node of the linked list points to one of the previous nodes in the linked list, then it just forms a cycle like in this example. So if there's a cycle, then we have to return true, and if there isn't a cycle, then we have to return false. So that's all that there is to the question, right? Now there are a lot of ways to solve this, but so there's a way that you can do this using hash maps, but that uses big O of n space complexity with big O of n time complexity, right? And what I want to discuss here is a solution that works in big O of n time complexity practically and big O of 1 space complexity, so constant space usage. And the algorithm is called Floyd's algorithm. So what Floyd's algorithm is, I'll explain through a dry run. So let's go here where I already have a linked list made out. And what Floyd's algorithm says is that you'll have two pointers, right? So one is called S for slow and one is called F for fast. Now in each iteration, you shift the slow pointer by one node and you shift the fast pointer by two nodes, right? And you keep doing this. So if you keep doing this and the linked list is just linear, the fast pointer will just keep going further and further away from the slow pointer, because in every iteration the slow pointer just uh, like goes to the next node, but the fast pointer goes two nodes away. And yeah, the separation between them increases by one in every iteration. So if this was just a linear linked list, the slow pointer would never be able to catch up to the fast pointer, right? They would never meet again. But if there is a cycle in the linked list, there is a possibility that these two pointers can coincide again. And this possibility actually becomes a certainty, and which means that if there is a cycle in the linked list, then these two pointers will definitely land at the same node again, right? And the way to see that is really simple. So, like I said, the separation between them increases by one in every iteration, right? But inside the loop, uh, they can't have a separation of more than four, right? Because there are just four nodes in this loop. So I can't say that the fast pointer can be four nodes away from the slow pointer, right? So what happens in that case is actually the fast pointer and the slow pointer are exactly at the same node. It's a basic concept of modular arithmetic. It's a cycle. So if the separation between them is as big as the number of nodes in this cycle, they'll just land up at the same node. And we can see this through a dry run, right? So uh, the fast pointer in the next iteration goes 2 nodes ahead, slow pointer goes 1 node ahead, fast, then in the next iteration the fast pointer goes 2 nodes ahead, and they're still not at the same node because the slow pointer moves 1 node ahead in the same iteration. And now in this iteration, the fast pointer moves 2 nodes ahead and the slow pointer moves 1 node ahead, and they're here on the same node, right? And yeah, that's basically it. So that is what Floyd's algorithm is, and coding it is really easy. So we can code it here, right? To code it, it's really easy. We just have to say make 2 pointers s and f, and both of them point to the head first. And I'll also use a variable called count here. So count is going to be initialized to 0. Now what I need to say is while f is not equal to none, right? And why am I saying while f is not equal to none? Because the fast pointer is always going to be ahead of the slow pointer, right? And in the case that this linked list doesn't have a cycle, the fast pointer will reach the end of the linked list, which is going to be a null value, before the slow pointer. So I just need to check if the fast pointer has reached the end or not to stay within the bounds, right? And yeah, so here what I'm going to do is I'm going to say if s is equal to f, I'm going to increment count, right? So whenever both of these point to the same node, count increments by 1. And right off the bat, they're at the same node, right? They're starting from the same node. So count is going to become 1 right off the bat in the first iteration of this loop, right? And then I'm going to say if count is equal to 2, which means if after this initialize setting, if they are ever at the same node again, if they are ever at the same node again after the initialize setting, then we should just return true, because this would only happen if there is a cycle in the linked list, right? And it will happen. This won't go into some sort of a crazy infinite loop. It certainly will happen because the separation keeps increasing by 1 every time. And if we follow modular arithmetic, we'll just land onto the same node eventually. Yeah, and if this doesn't happen, if count is not equal to 2, and we can still move ahead. So right, so we just have to move ahead. So s is equal to s dot next, and f is equal to f dot next. But like I said, the fast pointer moves 2 times, right? So here I should write f is equal to f dot next again, right? But I can't just directly write this because it's possible that when I do f is equal to f dot next here, f would have now become a null value in the case that this linked list doesn't have a cycle in it, right? So I can just check here that if f is not equal to none, which means that it's still pointing to a node and not a null value, then I can do f is equal to f dot next again, right? And that's it, I'm just done. So if this if there is a cycle in the linked list, this loop just keeps going on until count becomes 2 and it returns true. And if there isn't, then this loop is going to break sometime, and all I need to do is return false. So that's it. We can try running this code once, and it accepts it. That's good. We can submit it now. And that's great. So it works. And like I said, the time complexity is big O of n, and the space complexity is just big O of 1. So yeah, that's all, guys. Hopefully this was helpful for you guys, and thank you for listening to me. And yeah, that's all. Bye.